Hello Internet, my name is Quinn and this is Blondihacks. This is Mill Skills, a series of quick videos on learning to use your vertical mill. This is episode 6, Layout. Let's go. So what is layout and why do we do it? Well, if you watched the previous video, we just finished squaring up this stock here and getting it 2-dimension, and now we need to start forming features to get our actual part out of this block. And layout is a way to draw the features on the surface of this block and use them as guidelines for our actual machining operations. And layout is kind of an older school technique, and it's basically just applying colored chemicals to the surface of the part and then using something sharp to scratch lines into that chemical that you can see. So it's kind of like the opposite of what you would do in carpentry or other types of arts and crafts projects where you would use something like a pen or a marker to draw positive lines. We're covering the part in ink and then scratching in negative lines. And the reason that we do that is precision, because we can make a point very, very, very sharp and make very fine lines. You can't make a marker or a pencil that sharp. Even the very finest drafting pencil is still only good enough for the woodworkers. So that's why we do it this way. And even given that, it's still what I would call a medium precision process. You know, you can get within a couple of thousandths of doing this. It's useful to remember that not everything we do requires ultimate precision, especially in the hobby shop. You know, most parts that you make are going to have 1 or 2 or 3 dimensions on them that are critical to their function, and every other dimension, plus or minus a couple of thousandths, really won't matter. And layout is often faster than setting up, edge finding and, making everything perfect on the DRO. Precision costs time. And so if you want to make everything absolutely perfect all the time, that's great, but you're never going to finish anything. Now, if you have a DRO, and of course you have hand wheels on your mill, you might ask yourself, well, why do we bother doing this at all? And there's a couple of good reasons to still do layout. The first is that it's a great sanity check. If you're doing a multi-pass operation and you're trying to keep track of the depth of cut in your head, it's very easy to lose track of where you are. And having lines laid out on the part just helps you keep your bearings, helps keep you from milling out the wrong side of a part or, milling to the wrong depth or the wrong side of a line, things like that. And it's also a great sanity check for your drawings. If you're like me and you make your own drawings for a lot of projects, and if you're also like me and your drawings have a lot of mistakes in them, those mistakes will often come out in the layout process, especially with things like hole locations and intersecting radii, things like that. So layout helps keep you honest before you start removing material. So what is that colored chemical that we apply to the surface to scratch our lines into? There's 2 very common choices. First is Dicam, and this is a specialty product that machinists love that's specifically for this purpose. And it's basically like a cellulose product in an alcohol base, and the alcohol evaporates off and leaves a very thin chemical on the surface. This stuff is a little bit fussier to use than the other option I'm going to show you, but the great thing about it is its durability. You can put this stuff on at the start of your machining and it will survive pretty much to the end. It's resistant to cutting oil and it resists abrasion fairly well. So if you need to keep your layout lines through multiple operations over a longer period of time, this is definitely the choice. For quick and dirty jobs, there's another great option though, and that's our old friend the Sharpie. These big king-size Sharpie markers are great, and they will also do the job of putting a thin layer of something colored on the surface that you can scratch into. The downside to this stuff is it is not at all robust. So the cutting oil removes it. It doesn't stand up to any kind of abrasion. So this will not likely survive more than 1 or 2 operations, but often that's all you need, and it's a lot less fooling around than the Dicam is. So we'll start with the quick and dirty option, the Sharpie, and Yes, you just watched an instructional video on how to apply color to something with a Sharpie marker. There's nothing you can't learn on YouTube. The other great thing about Sharpie is that it dries very, very fast, so this is already ready to use. Now over to the Dicam. This stuff requires some technique for good results. If you just try to slap it on and expect to get a click spring video, you will be disappointed. So step 1 is surface preparation. The big thing with Dicam is that the surface has to be clean and free of oil. Oil is really the enemy of this stuff, and if you're getting blotchy, cloudy results with it, it's probably because you got some cutting oil or something on there. So prep work for this is acetone. So I'm going to give this guy a nice wipe with the acetone. And the other thing about acetone is that it's also the solvent for Dicam, so when it comes time to remove this stuff, acetone is your friend, and this stuff is quite difficult to remove any other way, so definitely keep a big jug of acetone around. All right, that guy is spotlessly clean, and let that acetone evaporate. Now, if you watch any amount of machinist YouTube, you've noted that everybody's die-chem bottle is a mess, and that's because this stuff permanently turns everything it touches blue, so hence the gloves. And just be careful around this. Don't get it on your clothes, don't get it on the cat, don't get it on anything else that you care about, because that thing will be blue forever. So after cleanliness, the next most important thing with die-chem is don't put too much on. When you first take it out of the bottle, that brush is super loaded up, and if you put this stuff on too thick, then it'll chip off, it'll flake, and you won't get nice clean lines. So you want to basically clean almost all of it off of the brush just by kind of tapping the side of the bottle there. And then it's time to apply it, and just try to do it in nice, clean, even strokes. And if it's a little bit thin, that's okay. We can put another coat on. But that is basically it. In addition to the prep work required, die-chem is also a little bit of a hassle because it does take a while to dry, and it's very important that you let it dry thoroughly. Give it a few minutes, because if you try to handle the part or scribe your lines too soon, you'll mess it all up, and then you have to clean it all off with acetone and start over. Okay, now we're ready to scribe some lines, and there's two basic and one controversial way that we do that. First basic way is the scriber. Second basic way is the height gauge, and the controversial way is the calipers. Oh, I can already feel the angry comment machine spooling up. Hold on, we'll talk about this guy. Let's start with the basic ways though. For many basic layout tasks where you don't need ultimate precision, you can just use basic drafting tools like a machinist scale and something like this awesome mini square from Barzy Industrial. And we can just apply that guy on there and scribe our line, and Bob's your uncle. Use very light pressure when you're scribing. You're just trying to scratch a line in the colored coating. If you press too hard, you're going to actually put a scratch in the part itself. And frankly, no matter what you do, you're going to get some very, very faint line on the part. But yeah, just use very, very light pressure. So here's a close-up of that line, and you can see I got a little bit of a ragged edge down here, and this is an area where the die-chem was a little bit too thick. So that's the risk that you run with this stuff. There's a technique to applying it properly, whereas up here you can see how I got a really nice, clean, sharp line. So up here, the die-chem was the correct thickness. It takes some practice to get really perfect results every time with this stuff. Okay, but it's time to step up to big girl layout, and that's the height gauge. And the height gauge is nothing without a very important thing in every machine shop. The surface plate. If you're watching my channel, you probably watch a lot of machinist YouTube, and so you've seen surface plates lots and lots of times, but you might have wondered exactly what they are, how they're used, and maybe even where to get one. So this is a very basic hobbyist surface plate. It's granite, as they typically are, and this is a 9 by 12 by 3 inch surface plate. These things come in just about any size. I mean, NASA, when they build spacecraft, they use room-sized surface plates that are feet thick and are amazingly precise. These things are graded, AA, A, B, or workshop grade. This is a 9 by 12 grade B surface plate from Little Machine Shop, and I'll put a link down there in the description. Hashtag not sponsored, but it is inexpensive and very precise. And the great thing about it for a hobby shop, as you saw in the intro to this segment, I was able to move it, which is how you know it's not very big. The thing about surface plates is they are incredibly, incredibly heavy. So if you're going to have one in your shop, you either have to have a dedicated area for it, or it has to be one not much bigger than this, or you won't be able to move it. And if you're doing really, really high precision stuff, you don't want to move it because moving it can cause shifting and settling. So grade B means that the surface is flat to within a 10,000th of an inch across the entire surface. And my experience with this guy is that it's actually a little better than that, which is nice. Proper care and feeding is very important for a surface plate because it is the most perfect flat surface in your shop, and you need it to stay that way. So that means you need to keep it clean. As you saw in the intro, I keep mine covered, and you don't want to let grit or anything accumulate on it. You don't want to scratch it. Don't drop anything on it. Treat this thing with a great deal of care and respect. If it does get damaged, the only way to repair it is to completely resurface it. And for a hobbyist grade surface plate like this, that probably wouldn't be worth the money. You'd probably buy a new one. So save yourself that trouble and just take care of it. And these guys are typically granite, although there are some cast iron surface plates as well. But granite is typically used because it's easy to grind and get a very, very high quality surface on it. And it's also very stable. It doesn't shift or warp a lot in temperature changes, things like that. It's immune to humidity and so forth. So it's a great material for this purpose. But what does a surface plate actually do, and why does it exist? This guy is the master reference surface for flatness in your shop. So what do I actually mean by that? Well, think about a typical milling operation. We put a piece of stock in this vise and we mill it flat. What have we actually done? We haven't really milled it flat by some universal, abstract, absolute standard. What we've actually done is made it flat relative to the bottom of this vise. And the bottom of this vise is flat relative to the underside of the vise. And the underside of that vise is flat relative to the flatness of this table. So it all comes down to how flat our table is, and of course how flat and parallel the dovetails are on the underside of this table as it moves. But for the sake of argument, let's just say that what we're milling flat is essentially flat relative to this table. So how do we get this table flat? Well, precision surfaces like this are either scraped in or they're surface ground. Now, if they're surface ground, all we've done is transfer all of these problems over to the surface grinder, and now this thing is only as flat as the ways and the table on the surface grinder. But for the sake of argument, let's say that we ultimately get back down to some flat surface somewhere that is now being scraped in. And scraping, if you've seen, say, Keith Rucker's channel, who does a lot of this, scraping is a process where you remove tiny, tiny amounts of material in a distributed pattern across the surface to make that surface perfectly flat. So how do you measure that flatness? Again, that flatness is relative. What's it relative to? The surface plate. When you hand scrape things in, you're comparing them and you're matching them to the surface plate. So the surface plate is the source of all flatness. And of course it doesn't stop there, because somebody had to make this surface plate flat, and so that came from some machine that makes surface plates, and that machine was copied and made flat from some other surface plate. And don't think about that too much, or you'll go crazy. But the point is, every shop has a surface plate in it, and that surface plate is your master flatness reference. And so you can see why, if I'm using these parallels to support work in the mill, then the resulting work will only be as flat as the quality of the surface plate somewhere in China that was used to grind and verify these parallels. Okay, but what does any of that have to do with layout? Well, because we know that this is flat, like super hella flat. What? Does anyone still use that word? Oh God, I'm such a dork. What I mean to say is that anything we put on here and or slide around on here is going to stay flat. So for example, the height gauge. So before we begin, like everything in machining, cleanliness is next to Renzettiness, so everything's got to be clean. So use your bare hand, because you can feel the tiniest little bit of grit on there. Make sure it's nice and clean. You can use like some simple green on there too if you like. And when we go to put the height gauge on there, you want to make sure the bottom of that guy is clean as well. Everything clean. And this will also help preserve the life of your surface plate. If you have grit in between things that you're sliding around, of course, it's going to score up the surface. Put that guy on there. Now we can put our part on the surface like so. Now earlier we put a line in 200 thou from the edge just using a machinist scale. Now let's do that same thing on the other side with the height gauge. So layout with the height gauge is kind of funny because you're doing everything vertically, so you got to kind of get used to that. So then we're going to clean the underside of the scriber here, and this is a carbide tipped scriber that's extremely sharp and extremely precise. So adjust the zero on this guy just like you would with a dial caliper if needed. And then down here we've got a scale, again just like a caliper. And so we can climb our way up. So that's 100. And there's 200,000. Okay, so now we know that the scriber on the end there is exactly 200 thousandths off of the surface plate. So now we can just lock that guy into position. Now the fun part about a surface plate is because it is so flat, it doesn't actually matter where we do this activity. We can slide things around with reckless abandon. And now we can just come in here and again, lightly, we're just trying to scratch a line through the colored coating. We're just going to go ahead and use the corner of the nose there on the height gauge and scribe our line. And you can see what a nice clean line that makes. And we know that the distance from the bottom surface of this part to that line is very precisely 200 thousandths. And that line is very, very precise. The only real imprecision in layout is when it comes time to mill to that line, because that line does have some thickness. It might only be a thousandth or two, but there's really where the error comes from, is when it comes time to mill down to that line. Now there are lots and lots of things you can do with a height gauge on a surface plate. I'm just scratching the surface here. Wait, that's a terrible metaphor. Don't scratch this surface. But let me show you a couple other things. So for example, I can come in here, measure the height of this block, and we see that that's 978 thousandths. So now I can come off of this guy and come down to 489 thousandths. And when I get close, I can lock this guy in right here, and that engages this fine feed. And then I can dial in to my 489 thousandths like that, and then lock that guy, and then scribe it. And now I have a perfect center line on my block. And by extension, you can see how if you're working from a drawing, you're going to have a bunch of features that you're trying to lay out on this surface. Just imagine you're drawing vertically, and you can do it all with the height gauge. Now, something to watch out for when you do that, if you're laying out features from a drawing, maybe you've got a bunch of bolt locations and some recesses or other things, make sure that you're doing all of your layout from one reference corner. So always from the bottom, and then if you need to do lines in the other direction, always pick one end, and so this corner becomes my origin. So you want all your features laid out from that origin. Don't measure features inward from the edges, because your block is never going to be perfectly dimensioned, and so whatever error you have on those dimensions is going to get accumulated now when you start measuring features from those edges. So I always like to just mark a 0 in one corner, and just so I don't lose track of where it is, and then do all of your layout from that corner. And one last great trick I'll show you with layout is locating holes. So I've gone ahead and used the height gauge to make a center line the other way on this block, so we now have a little cross right in the center of our part. So let's say that we wanted a hole right there. Well, now we can take our center punch, and the great thing about these layout lines in the die-cam is that you can actually feel them with the punch. You can put the punch in one of the lines and slide it forward very gently, and you'll feel the intersection between the two lines. And then you just carefully hold it up vertically and punch it, and then check it. And if you're a little off, you can move it, as I showed in my common machining mistakes video. You can punch this guy at an angle a little bit and move the punch around until it's right on your layout lines. And then when you set up on the mill to drill this guy, we just need to get the spindle aligned with that punch mark. So you could do that with something like a wiggler, but depending on what size that hole is going to be, there's a couple of easier ways that we can do it. If it's a small hole or you don't need ultimate precision, then just lining up your drill with that punch mark might be enough. The drill will tend to find that punch mark and take itself home. But another way to do it that I like is to put a center drill in there and bring that guy down and line it up by eye, and just kind of work your hand wheels until that center drill is lined up, and then just give that guy a little spin by hand, and then you'll see it make a little divot, and if that divot is centered on your layout lines, you're good to go. So now you can go ahead and center drill that for a large drill, or if it's a smaller drill, just put that drill in and send it home, because now you know that your spindle is centered on that mark. And again, this method is going to be precise to within a few thousandths. If you need more precision than that, then you're going to be using the hand wheels and edge finders and the DRO and other methods, which we'll talk about in a later video. And there's a nice hole right where we wanted it, all thanks to old school layout, our friend the surface plate, and our friend the height gauge. And you can see how the die cam stands up to the cutting oil and the scratching of the chips and so forth. It holds up quite well through multiple operations, whereas the Sharpie marker would be mostly destroyed by now. But I'm not getting off that easy. I said I was going to talk about the controversial option, and here it is. Now I'm showing this at the end because all the haters have found something else to get mad at by now and have already rage quit after leaving some nasty comment that I've already deleted by the time you're seeing this. So let's go ahead and put a 200 thou edge line on there again, just like we did with the other two methods. So I just set this guy to 200 thousandths, and I lock that guy. And of course you have to have a machined side to do this trick. So I'm going to do it on the end here where we don't have a line yet. And so all you do is rest one jaw on there, and the other jaw goes on the bluing, and we just go like that. And there we have a nice clean scribed line, exactly 200 thousandths from that edge. So why might we use this method over the other two that we've looked at? Well, first and foremost, because it makes YouTube commenters super angry, and I like to observe trolls in their native habitat. But secondly, as you saw, it's very quick and very convenient. So for a lot of layout jobs, you just can't beat it for the speed. But of course, when you do this, use very gentle pressure. You're, again, just trying to scrape through the layout fluid. You're not trying to dig in and scribe marks into the material, which would, of course, be very bad for your calipers. But again, you're just using very light fingertip pressure is all it takes to make a mark, and that's not going to hurt these guys. And then when you're done, you just take a nice clean paper towel and some acetone, and takes that bluing right off of there like it was never there. And that's it. Job done. And that is surface plates and layout in a nutshell. I hope you found this useful. Consider supporting me on Patreon. You know, my awesome patrons keep the lights on here. I don't have sponsors. I don't get revenue from really any other serious source besides Patreon. So thank you all who support me, and we'll see you next time.